Okay, good evening everybody. I hope you're all fed and watered and ready for this. Well, because 5G is going to touch all of our lives in the future. Every single day we are going to come into contact with 5G. We may not know it, but we will. Okay, so this is me. My company is called Route 21. We're a business accelerator. We work with startup businesses in the sort of Hampshire area. We work with them on getting their businesses up and running and understanding what their business is about, getting them to a point where they can raise investment if that's what they need. And alongside that, we run a 2-day entrepreneurship program where we'll take in up to 30 companies and we put them through a 2-day kind of boot camp of how to get their business up and running. And what we really focus on, because when the companies come, they know all about their product and what they want to do with their product, but they haven't thought about why does their business exist? What's it trying to do? And that's what we get them to think about on this program. Along with that, I've been involved with a catalyst program that we've run in Somerset, which is how I come to know David. I've been working with David on his business. But we also work with established companies. So we have a program called Think Like a Startup, which is to help established businesses to become more innovative, more entrepreneurial, because often they're so stuck in business as usual, they don't know what they need to do to kind of break out of that. In addition to that, I worked with the 5G Innovation Centre from Surrey University, which was has been the main 5G facility for some years in the UK. I worked on the SME engagement programme for them there, and I'm also part of UK 5G's working group for SME engagement, and so that's a national group that looks at how to engage SMEs with 5G. Okay, so that's enough about me. What we're going to look at tonight is firstly economics. So why do we need 5G, first of all? The science bit, how does it work? Applications, what difference is it going to make? What's it going to change? And then what is the impact of 5G? What capabilities does it give us that we don't have today? And then I'm going to run through some case studies of some of the trials programs that have been run in the UK. There's been a lot of government money that's gone into funding these trials programs to try to see what the potential of 5G is for the UK. And then finally, we're going to just have a quick look at what's been the rollout of 5G so far. Okay, so why do we need it? So first of all, as a country, we need to be engaged with this because there are countries all around the globe who are putting massive investment and massive time into their 5G networks. And if we don't do the same, we are going to get left behind because they will enjoy benefits that we don't. And so it's really important as a country that we digitalize. And as I said, that's why the government has put a lot of money into trials programs. But it's not so much thinking about how does 5G work. We will talk about that a little bit in a minute. It's not so much about that for most businesses. It's about thinking, what are we going to do with it? When we can connect to the internet wherever we are and get whatever performance we need, what are we going to do with it? That's where the business opportunity is. And that's why I do these talks to try to get people to start thinking about it. Because the 5G rollout's still quite early, and so it is a time when you can think about how are we going to leverage it? What are we going to do with it? And so these are the things, the GSMA, which is the global standards body for mobile communications. These are the things that they came up with, which are important for the digital economy. I'm not going to go through them all, but I think some key ones are training, the skills, people that are able to deal with digitalization. And maybe a surprising one, locally relevant content and services. I think those are two really important things to think about as a business. How can we help with these? But ultimately, for tonight's discussion, it comes down to infrastructure, right? Because if we don't have an infrastructure that we can connect to the internet, then we don't have anything. And so what we need from this is something that's reliable, that's fast, is ubiquitous, so that means it's everywhere, and is mobile. And so that's what 5G is. So, research has shown that people that embrace mobile technologies, achieve amazing results above those businesses that don't. And so, if nothing else, from a business perspective, we want to be taking advantage of this. But there are other things driving it. So we've talked a lot here about the macro economy and what's driving mobile adoption. But what else is there? What are the other things that are driving this transition? Well, here's some research just to kind of reinforce that. So this is looking at the number of devices out there in the world that are smart. And you can see in 2022, 85% of devices now that are out there are smart. They're not just dumb things, they're full smart devices. In the next couple of years, you could well see that going above 90%. So that has an impact. Mobile data traffic. This year, it's predicted to be 77 exabytes. So a byte is the standard definition or the standard unit of data transmission. An exabyte is a million, right? So 18 zeros, right? That's how much data this year. And there's some research that came out is when is that data being consumed? In fact, it turns out Sunday evening, there's more data shipped on a Sunday evening than the rest of the week put together. And it's because people are on a Sunday, they just want to chill because they're going back to work on a Monday. So they're streaming stuff, they're downloading stuff, they're playing games, that kind of thing. And so that's what's driving this massive surge in data. And our existing networks just won't be able to cope with that. And finally, the growth in things. So things are not people, they're not mobile phones. They're sensors or they're machines. They're things that operate without humans being involved. And we can see 39 billion connected devices globally now. You can see the growth rate. And that's why I said at the beginning that the opportunity in 5G is for businesses, because this is all business use. It's sensors, people monitoring stuff in facilities or out in the field, people using robots, people using drones. All that stuff is being controlled via a network somehow. Might not be 5G at the moment, but it will be in the future. And so, 5G has to be deliver more than our existing networks to take advantage of this. So right now, this is where 4G sits. Mobile broadband. 4G is aimed at people. Right? It was to deliver that mobile broadband experience. But in the future, we need to be able to talk to things. Critical communication. Some of the emergency services now are starting to use 5G instead of their regular, they used to have proprietary radio systems. They're starting to use telco networks now because of these things. It's ultra reliable, it's ultra available. That means it never goes down, or it very rarely goes down. If you're in a blue light service, you can't afford for your communication not to be working. Right? Someone's going to die if that happens. And so these capabilities need to be built into 5G. This is an interesting one, something we call the tactile internet. Okay, a good example of that is remote surgery. And so using a 5G network, as long as you're not too far apart. The surgeon doesn't need to be in the operating theatre with you. The surgeon could be somewhere else. And the surgeon is controlling a robot over a 5G network to actually do the surgery. And that's where this thing is important, low latency. Latency is about, if I make a movement here, how quickly does it respond at the other end? Obviously, if you're doing remote surgery, you want it to respond pretty quickly, right? We don't want to go to make a cut here and then 5 seconds later it actually cuts at the other end. Something's going to get cut within one cut, right? So this is why that's important. And then over here on the other end is massive IoT. This is sensors in the main. So they might be measuring things like air quality, temperature, humidity, these kind of things. And these have, again, completely different demands. They're very low-cost devices. They need to have long battery life, and they don't actually send much data. So what we can see is that 5G needs to be able to handle a diverse set of devices, from the very smallest to the most powerful. Because on the other hand, it's still got to handle mobile broadband, but it's got to be able to also deal with these other things. So how is it going to do all of that? You know, we know what it needs to do now. So I'm afraid we are going to have to get a little bit technical now, because we're going to have to understand how it does it. What are the things that are different about 5G versus 4G that means we have to have 5G to do all of those things? And so the promise of 5G is that it doesn't matter where you are, what you're trying to do, you can connect to the internet and you can get exactly the performance that you need. And you have this perception of infinite capacity. What do we mean by that? Well, as far as we're concerned, we've got as much data as we want, we've got as much signal as we want. As far as we're concerned, we don't need to worry about that, because we have that perception of infinite capacity. So the analogy I use there is with electricity, right? When we plug something in the wall, we don't think to ourselves, I wonder if there's enough electric there to run that thing. We take it for granted that there is. But that doesn't happen by magic. You know, we don't have infinite electricity generation, as we're all starting to find out in these current weeks. And so how does it work? How is it that we can always plug something in there and always know there's enough electricity there to run it? Well, there's a bunch of guys sat in a control room somewhere balancing the load across the country. They're looking at all the demand across the UK. They're looking at where they've got electricity generation capability, and they're trying to balance the two things up so that everybody gets what they want. And that's what 5G will be like. Except it's not a bunch of guys sat in a room, it's software running in the cloud that's constantly looking at what's needed in the network, the number of connections, the performance that is needed. It's constantly looking at that, building the network up, and then when things change, tearing it down and building it back up again. So everybody gets exactly what they want. And this is a big difference with 4G. When you connect to a 4G network, you get a 100 megabit pipe. And if you're only downloading emails, you don't need that. So the rest of it is wasted. In 5G, it will create a piece of the network that's exactly the right size for what you're trying to do. So if you only need a few bytes of data, it will create a piece of the network that's just a few bytes. If you're streaming a video and you need 20 megabits, it will create a piece of network to give you that. And so it's constantly looking at what's the demand across the network and rebuilding the network to cope with that, redistributing the resources that it has in the network to meet with demand. So that's what it's doing. And there's some very clever stuff behind all of this. So first of all, there's more licensed spectrum. So a mobile phone is a radio device. And if you're operating a radio device, you need radio spectrum in which to operate. For mobile telecoms, that spectrum is licensed by the government. And that's why you hear about these auctions that go on where people are paying obscene amounts of money for spectrum. And so if you're in a 4G network, we basically operate more or less in one band for 4G. But in 5G, we operate in three bands. There's a low band, there's a mid band, and there's a high band. And so at the low band, we might be at, say, 700 megahertz, the mid band, 3.5 gigahertz, and at the top end, 26 or 28 gigahertz. Why do we need all that, you say? What's the point of it? Well, there's a trade-off between data rate and cell size. So at 700 megahertz, we may only get 10 megabits a second, but the cell size is tens of kilometers across in diameter. In the mid band, we may have 10 or 15 kilometer cell size and maybe up to a gigabit in that band. At the high end, we can get up to 10 gigabits at the high end, but the cell diameter probably is only 100 meters, 200 at the most. So you end up with very, very small cells at that high end. And even worse, at the high end, the signals won't go through a wall. So we're all used to being able to pick up our mobile network indoors. You won't be able to do that at the high end. You'll have to have 5G, effectively 5G antenna in the room. And so this gives us, why do we want to do all this? Well, it gives us flexibility, right? So we can trade off now what performance we want versus what coverage we want. And coverage, as we all know, has been a big issue in this country. You know, I came down on the train today and there were spots where I was dropping back to 3G, had mostly 4G, but you know, so coverage is a big issue. And so if we can use these very big cells to supply a kind of base level of performance, that's where potentially that universal coverage can come from. And so that works into this thing that we call ultra-dense networks. And so here we can see quite a big cell. This is probably in the mid-band. And then we've got lots of very small cells here, which would be at the high end. And so why would we want to do that? Well, if we're in a sports stadium, or we're at a concert, or we're at a festival, there's lots of people in a very confined space, all wanting to access the internet at the same time. We need to be able to deliver a lot of bandwidth, but not a huge amount of coverage. You know, if we were in a football stadium, maybe we put 10 small cells in, we could cover the whole stadium with 10 gigabits of performance. And so that's what these two things together give us. It gives us the ability to trade off coverage versus performance. And actually, there's two elements in any mobile system. There's the radio part of it, which we've talked about here. That's the thing that connects you to the network. But then there has to be something that decides, okay, you want to connect to that website, or you want to connect to that over mobile phone. That's something that's sorted out in what we call the core network. So the core network is the thing that's making the connections. So the radio bit connects you, and then you can kind of think of the core network as like a telephone exchange. It routes you through to wherever it is you're trying to get to. And that all sits in the cloud. So it's using cloud technology. That's the basis of pretty much everything on the internet these days now. We've all got our photographs in the cloud. We've got our music in the cloud. We're streaming stuff. There's a lot of technology that was developed over the last 20 years for cloud computing that is now being repurposed for telcos. And so the mobile core network basically becomes a big piece of software, an application that runs in the cloud. And that's how it works. And you know, it's important to understand that, because that's where the intelligence sits to say, okay, how do we need to build this network based on all the demands we've got now? How are we going to build this network? That's the bit that's deciding it. Who's heard of a company called Salesforce? Right, Salesforce were the first people to ever implement cloud computing. When they developed the company, cloud computing didn't exist. They were the first ones to do it. So that gives you an idea of how long this technology's been around. Salesforce has been around 15 years, maybe. And so the point is, this core network, actually, from a radio perspective, it's agnostic. It doesn't care really what the radio is. It could be 5G, it could be 4G, it could be 3G. It could even be Wi-Fi. So if you're somewhere and there isn't any cellular coverage, but it has access to a Wi-Fi network there, it can connect you through that. Happy days. And of course, the final thing is it has equal support for things as people. So it was designed from the beginning to be able to deal with inanimate objects rather than people. And why do they need to be treated differently? Well, for things, these are often sensors, so they're very low-cost devices. We all know how much a handset costs, right? We can't afford to load that on. A sensor maybe costs a few pounds. So we can't load hundreds of pounds of cost on it just to connect it to 5G. So 5G has had to be adapted so that we can minimize the complexity in these devices, so they can connect to 5G without a big additional cost adder to them. They're also often, they're remote, they're out in the wilds somewhere, so they're not very accessible. And so they have to run off a battery for years. Again, you know, we all know how long our mobile phone stays charged, right? So again, we can't have that. We can't have it something having to go out there every 5 minutes to put a new battery in. It has to work for years unattended. And so there's been a lot put into the 5G standard to cope with that. Deep coverage, as I was mentioning with the high end, that it won't go through walls. Well, worse than that for IoT, some of these things are like 6 feet under the ground. They're in sewers, they're in water pipes. You know, we've got 6 feet of concrete and earth and stuff to get through. And so they really need to have deep coverage. And there's lots of them. There's potentially thousands of them in an installation. And so this is why 5G is needed, because 4G cannot do any of this. And finally, well, imagine if your car could talk. That's what V2X is about. And it comes into these three things. So first of all, vehicle to infrastructure. Your car can talk to a lamppost, can talk to a traffic light. It could talk to a matrix sign. We'll talk about in a minute why we want to do that. It can talk to another vehicle, vehicles that are around it. It can even talk to a pedestrian. It's obviously not talking to us directly, it's talking to our mobile phone. But the reason to do all of this is it gives the car a perception of what's around it, where the other vehicles are, where they are in relation to traffic lights and lampposts and things like that, where they are in relation to people. And so one of the big things is accident reduction. We can avoid car crashes because we know there's another car coming out here, and if we keep going, we're going to hit it. Or there's somebody coming around the corner on a push bike that we might knock them off their bike. So there are safety elements to knowing that. But with infrastructure, how many times have you been at a traffic light that's on red and the other lanes are on green, but there's no cars there? And you're sat there getting really frustrated because why can't I go? You know, there's nobody there. In this case, the car would know and would signal to the traffic light, and the traffic light would change to green and let you through. So you get these efficiencies in traffic management. Okay, you'll be pleased to know that's the end of the technical bit. Everybody got that, how it works, why it needs to be different. I mean, not in detail, but you know, you appreciate why it needs to be different and why 4G cannot do all of these things. And this is really important because all of these things we're talking about are more important to a business than a consumer, right? And so again, I want to emphasize, we need to be thinking about business using 5G, not as consumers. Okay, so we're going to look at some of the applications now, what we can do with this. So firstly, media and entertainment. So we're all used to already streaming stuff to our mobiles. So, you know, ultra high fidelity media, we can probably pretty much do that with 4G. If we went to 8K video, which some people are talking about now, we wouldn't be able to do that with 4G. Event experience, that's what I talked about just now, where you know, we're at a football match and we want to see the view from behind the player who's taking the corner. The stadium can make that available to us. But if everybody wants to see that all at the same time, there's a huge requirement for data. And so, again, 5G network could cover that stadium with a 10 gigabit network, and that would all work fine. User-generated content. We are more and more generating this content that's on the internet as individuals. Stuff we upload to social media, you know, YouTube and so on. So again, a lot more data needing to go up. Virtual and augmented reality. That's been used a lot in gaming until now, but it has huge applications in business. Training, for one thing. You can put people in an environment that looks real to them, but isn't real. And so one of the things that's been done, before you're allowed to go on a ship, you have to do a familiarization exercise so that you know where everything on the ship is and how to get from place to place on a ship. That's very costly to do at the moment because they have to wait until the ship's in port before you can do it. And so there are virtual programs now that have been generated, and they put the goggles on and they're, to all intents and purposes, they're on the ship. They can walk around the ship, they can see where things are, they can do pretty much everything as if they were on the ship without the ship being in port. So training is a big application for that. Control systems, rather than having a big physical control panel to control a process or a production line, kind of it's virtual. Then if we need to change it, we can just add bits to it or we can take bits away, very, very easy. So there are lots of business applications for virtual and augmented reality. We're going to talk a little bit more about that in a minute. And lastly, collaborative gaming. So more and more now, I'm sure you know your kids are not just playing a game on their own. They're playing against a whole group of people that are all on the internet. And as those games get more sophisticated and those games end up being in the cloud, which again we'll talk a bit more in a minute, more bandwidth is required, more performance is required from the network. And automotive. So we've all probably all heard about autonomous vehicles that drive themselves. We just sit back and let the car drive us around. That needs a lot of information about route planning and so on, even in addition to things that we just talked about collision avoidance, traffic management and those kind of things. And so that all comes under cooperative traffic management. This is where vehicles are cooperating with themselves and with infrastructure to make the traffic flow more smoothly. The digitalization of transport and logistics, again, we've got a case study on this, but that's about supply chain management, making sure that when we need something in a factory, it's actually there. And a lot of factories now have a hard, just-in-time supply chain that they operate. And what that means for some is that the parts only arrive at the factory 15 minutes before they are built into the product. So you can imagine how tightly that has to be controlled. If it doesn't turn up, the whole line is stalled. And downtime in a factory is very expensive. And of course, internet and media. Well, when we were sitting in our cars, they're driving themselves around. What are we going to be doing? We're going to be watching movies and playing games, and so we need to be able to deliver those kind of things into cars as well. Okay, energy management. A lot of applications here. So we're quite familiar, I think, with building management and smart metering. You know, a lot of big buildings have had control of air conditioning and temperature and those kind of things for some time, but that again is moving on to 5G. But some of the more interesting things are smart grid. So we're generating now more and more of our electricity through renewables. But those things are highly distributed. In terms of power stations, you know, we've got, I don't know, maybe 20 power stations around the country that produce all the power. But with wind, they're all over the place. They're at sea even, you know, and so it's managing all of that. When are we going to take power from wind? When are we going to take it from solar? When are we going to use gas? What's happening with these windmills out here on the west coast compared to these that are on the east coast? All that needs to be managed, and it needs a network that these things can communicate back to the central controller what's actually happening in those places. And that enables us to do environmental management. Once we know where the electricity is coming from, we can decide to use the most environmentally friendly. So we can say, the wind's blowing today. We're going to take all our electricity from wind, and we're going to turn down the gas on the power stations. So it gives us that capability to do those kind of things, and remote control of these devices. Again, they're out in the wilds. You know, they're not very accessible. They're in very remote areas, sometimes very hostile environments in the North Sea, for example. And so being able to control these things from the land is really important. Factory of the future. So factories are using robots more and more and more to control manufacturing processes. They can also look at energy efficiency. So if they've got access to more environmentally friendly sources of electricity, they could choose to use that in their facility when it's available, or gas when it's not. Supply chain connectivity we talked about is, you know, they need to be able to guarantee when they can get stuff to the factory, and that comes through connected goods. What I want to talk a little bit about here though now is, actually I'll talk about it in the case study. I won't talk about it now. Finally, healthcare. This top one is classic, asset management. Have you ever been in a hospital and you've seen, I don't know, some kind of monitor or something, and it's got a bit of masking tape stuck on it with the name of the ward written on it? Have you seen that? That's how they do asset management today, right? So if somebody comes and takes that away to another ward, no one knows where it is. All right, so asset management in a hospital is really a key thing, because equipment just goes missing. No one knows where it is. And we can tag all of that in a 5G network. We can know exactly where it is. These ones have been talked about a lot, personalized care and telemedicine. So this is where we don't have to go and visit the doctor. The doctor can be monitoring our vital signs and almost, preempting treatment for us. So, you know, the day will come when you get a call from the doctor that says, I've been monitoring your blood pressure and I've realized it's a bit high, and so I prescribed some drugs for you. They're going to arrive in the mail. And that will be the consultation, because the doctor will have access to vital signs from you. They'll be able to monitor your health, and that's what telemedicine is. And personalized care is around social care. So that's, again, making social care, individual social care packages that are managed via the internet. Precision medicine is where we are designing drugs specifically for you. Based on your DNA, they will design a drug that works specifically for you. And so why would we want to do that? Well, when you get some drugs from the doctor, you take out this piece of paper that's like this long, with all the side effects. Right, why do we get those side effects? Because those drugs react with our particular DNA and cause a side effect. If we can tailor a drug to your DNA, no side effects. Okay, as well as they're more effective. And remote surgery, I talked about that, using robots to do surgery. So again, big impact on healthcare. So the 5G impact, what does it enable us to do that we can't do at the moment? Well, because it's essentially in the cloud, it gives us access to powerful processing. So we're not anymore constrained by the capabilities of our handset. We can process whatever we want because we can scale up processing in the cloud to do things, the most complicated things we ever want to do. Everything can be measured and can be analysed. So we're not guessing anymore. We can record data, we can take it up into the cloud, we can process it, analyse it, and make some sense out of it. Because, you know, data without analysis is just data. Data with analysis is intelligence. Once we have intelligence, we can make decisions. And it's fast. And it can present things back to us in a visual way. We are visual animals. Right? We're much more at home with pictures than we are with words. And so we are able to present these things back visually. So they're easier to understand. And they're mobile. We can be anywhere doing all of this. So that's what 5G gives us. And that's what we need to be thinking about with our businesses. What can I measure that could then be analysed that would enable me to do something that I can't do today? Or I'm trying to do it with a spreadsheet and it takes me all day to figure it out, and by the time I figured it out, it's too late. It's instant. So I'm going to look now at some case studies that kind of reinforce this. And the first one is immersive experiences. And this has applications in virtual and augmented reality, but in streaming, gaming, and, believe it or not, tourism. I'm sure in this county is a hot topic. So, first of all, the future of gaming. Google announced this platform a few years back now called Stadia. It's completely in the cloud. Right? So the game runs in the cloud. What does that mean? Well, it means that we're not any more restricted by the limitations of the console that we have. So we come to this point every now and again where we've got these new super games coming out, but they only run on the latest PlayStation or the latest Xbox. So we've got to throw away the old one we already got and buy a new one. Running these in the cloud can scale up to deal with a more complicated game. We're just streaming it from the cloud to our handset. So that's all the capability we need in the phone, is to be able to stream video. And that's where cloud gaming is becoming a big thing, because it's more immersive, it's more reactive. They can update the games more quickly. They can change things on the fly in the games if they want to. And increasing the resolution, they're trying to push up to 8K video now. I don't know about you, I haven't even got 4K yet. And so how does 5G enable all that? Well, it's speed and low latency. If it takes too long when we're playing a game, if it takes too long for the game to react to something we've done, we notice it. And it's not much, it's less than a second. If the delay between me doing something and I actually see it on the screen is if it's more than probably half a second, we notice it. And there's this thing called edge computing, which means that actually we have servers at the edge of the network as well. And so we don't have to go all the way back to the core. We can have some servers very near to where we are so that we get the response times that we need. Because obviously the further away the core network is, the longer it takes to go there and come back. And so again, that means these things, more reactive games and removing the console limitations. In the end, you could see that a mobile phone would just become a display device because all the processing would be done in the cloud. I don't think it will get there, but you know, in theory, you could get there. Okay, well, what about tourism? So this was one of the trials programs that was done in Bath. And it was done by these guys, BBC, Ardman, and University of Bristol. And what they came up with was an augmented reality application for going around the Roman baths in Bath. And so it's triggered by hotspots as you go around. And so what you do is you hold your phone up, and then you see obviously what's there for real, but then part of it is replaced by video on your phone. And it then displays additional information for you and additional facts. They covered, I think, 3 periods in time. But what that means is they need to recreate that 3D scene and match it. So they need to know where your phone is in relation to the real scene. And they need to match that video that they create so that it looks seamless. So it's a huge demand on computing and the network. And that's one of the reasons why they did it. And so you can go around the Roman baths now, and you can use this app. Here's a couple of screenshots from it. But that was one of the trials programs that the government funded. And so, you know, again, what do we need? We need speed because we've got to orient the data. We've got to do all the scene matching. We've got to do that quickly, so we need low latency. And we need edge computing so that all that can be rendered very close to where you actually are. And then all those scenes are rendered in the cloud, and it removes all the complexity from the handset. And so this is, you know, quite an exciting development for tourism. Because you can imagine what they've done there for the Roman baths, you could do anywhere, any tourist visitor site, you could go there and have a similar application. Next is industrial automation, something called the 4th industrial revolution. So we've had 3 already. This is the 4th one. And what's the 4th one about? Well, it's about this, actually. So if we go back in time, 1850, you know, up to sort of early 1900s, everything was craft production, right? So it was craftsmen, hand making everything, churning them out in small volumes. And then around about here, we moved into this cycle, peaking in the 60s, of mass production, where everything was mass produced, but everything was the same. As Henry Ford said, you have any color you like as long as it's black, right? Because all the cars he made were black. That's what mass production gives you. Very cheaply, things that are identical. But now, of course, we all want things personalized. We don't want to have the same thing as somebody else has got. We want our thing to look different to everybody else. And so, you know, in this sort of time frame here, we've started to move into this time of mass personalization, where everybody wants something different. And if you go and buy a car now, they don't say, well, I got a green one, a red one, and a blue one, take your pick. They say, what do you want? What features do you want on it? What trim do you want on it? What do you want leather seats? And that car is made to order. And that's what's starting to happen. And because of that, a lot of this stuff, you know, consumer stuff is manufactured in China. And what they're having to do in China is, you know, one week they might be making iPhones. The next week they may be making, I don't know, TVs. And so they're constantly having to reconfigure their production lines because they don't know week to week what they're going to be asked to make. And so why am I telling you all this? Well, because now what people are doing is saying, well, instead of having robots that are fixed, why don't we have the product fixed and the robots move? And so there's some trials going on now where the production line is like a big ballroom. It's just a big open space. the car is built in one place and the robots come to the car, do things, some more robots come and do some other things, and they build the car in one place. BMW's doing this at the moment. And so, well, what does that mean? Well, now, most of these robots at the moment, the way they're connected to the network is via a cable. Well, if you've got robots flying around all over the place, you can't very well have them having a cable dragging along behind them. At some point, one of the other robots is going to run over it. And so they need a wireless network to make all this work. And 5G is pretty much the only solution. Wi-Fi doesn't support enough nodes for this to work. And so they're all looking at 5G installations. Now, one thing I want to talk about here now is something called private networks. Because, you know, in the past, we've all been used to waiting until the operator has condescended to roll out the latest generation to our town or city. And so until that's happening, we're just sitting there and waiting for them. With private networks, we can build our own network. And indeed, that's what these guys are doing, because they don't want their internal network on the public cellular network. They want it isolated. And so they're building a private network using 5G technology. And indeed, through a scheme called spectrum sharing that Ofcom is putting together now, if an operator won't come to your area because they say it's not worth it, you know, there's not enough people who live there, we're not going to do it, you could say to them, well, if you're not going to do it, we want to use your spectrum and we'll build our own network. You can do that with 5G. So as a community, you club together and we say, okay, you know, we're going to make this happen. We're going to have a bit of Vodafone spectrum or whoever, and we're going to build a network in our village. And there's a company that's done that with broadband. It's a company called GigaClear. I don't know if you've heard of them. But what they did is they went to small villages where BT was never going to roll fibre out there, and they said, look, if you all agree and you sign up to a contract, I think they had to agree, you know, £60 a month or something for a certain number of years, we'll come and put it in just for you. And that was their business model. You could see the same thing happening with 5G. So, as I said, they need speed, they need cloud computing, there are lots of devices. It has to be reliable. We can't have the factory going down every 5 minutes. It needs to have low latency, no cables, and that capability for VR and AR, because there's still going to be people there monitoring what's going on, and they might want to see a view of that that's virtual rather than real. Okay, logistics. Efficiency is everything in logistics. So here's some research looking at chief information officers in logistics companies versus chief information officers generally, and what they rated. So this one here, improving business efficiency. The top one is logistics. 68% of people in logistics want to improve business efficiency. And 30% of them see the Internet of Things, or IoT, as a key enabling technology for them to do that. And it turns out, you know, as we said, just in time, they need to get them there. But it turns out what they know is they know when it left somewhere and they know when it arrived somewhere. But they don't know what happened in between. They don't know if the driver stopped off for a couple of hours somewhere. They don't know if he took the best route. And so they all say, we actually want to track it from when it leaves all the way on its journey until it arrives. We want to be able to track all of that. And that's the opening there for 5G, because then once you have a 5G network there, you can put sensors on those trucks and you'll know exactly where they are, how well the driver is driving it. One of the biggest factors in cost for logistics companies is drivers driving badly, using up the tyres more quickly, using more fuel because they've got a heavy right foot. So they are really interested in being able to monitor driver performance. And so that's things like vehicle management. So again, they can check what's happening with the vehicle, whether it's running properly, those kind of things. And so they need the same things, really, artificial intelligence and machine learning to analyze all this stuff and to give them intelligence about what's actually going on. Now, lastly, smart farming, or what's sometimes called precision agriculture. Sorry. So there's a big drive to increase productivity and to increase the quality of what farmers are producing and the quantity. So not just one or the other, but both. We need to get more food out of a square acre or hectare of land than we are at the moment. And that food needs to be higher quality than it is at the moment. And so the only way to do that is increased automation. Because on farms, there's fewer and fewer people now. If we went back 50 or 60 years, I don't know, you might have had 10 or 20 people on a farm. Now it's probably 1, 2 or 3, depending on the size of the farm. So there's not a lot of people there to do this. And they are trying to cover vast tracts of land. And so they need to improve quality and quantity. They need comprehensive management. They need to know what's going on with their crops and with their animals on a constant basis. So they need to be able to check, is the animal healthy when they're out in the field somewhere? They need to be able to check if I've got infestation or, if I've got a drought, the crops need to be irrigated. We need to be able to monitor all that stuff and feed it back. And another big thing for them is supply chain traceability. It's becoming more and more important that we want to know, where's our food come from? How did it get to us? And so supply chain traceability is another thing that they have to contend with. And whilst doing all of this, of course, reducing their environmental impact. And so 5G can help with that because it can use sensors, cameras, robots, and drones. A drone can cover a field in a very short period of time. It can identify where there are weeds, and it can independently kill an individual weed. So rather than spreading a weed killer across the entire field, you just put it where the weeds are. Same with irrigation, same with fertilizers, same with animals out in the field. You can have a drone up that's monitoring animals out in the field, seeing if there's one that's lame or something like that, so you can address it more quickly. And so we need that real-time data analysis. And similarly, we've got a high number of devices. We can have perhaps sensors in the soil that are measuring the soil chemistry. We can have sensors on the crops that are measuring whether they're the right size and so on and so forth. Okay, and there was, again, another of the 5G trials that the government funded was something called Rural Dorset. And so that was a completely agriculture-based trial. And at the end of this trial, they concluded that they could increase yield using 5G. They could increase yield by 200%, and they could reduce the use of chemicals and pesticides by 95%. So that was the research that came out of that program. And so you can see that this technology is going to have a big impact on farming. And again, that's probably all going to be private networks. Okay, so we're nearly there. The rollout. So the story so far. So around the world, according to ABI research, there's now 1 billion 5G subscribers all around the world. So I don't know, what's it, 6.5 billion people in the world, so it's about 15%, something like that at the moment. And so it's important to understand that the rollout is right at the start. We're only 2 years into 5G, right? And so, you know, now is the time to be thinking about it because it's early enough. And surprisingly, UK 5G did a survey. They surveyed 300 companies. Don't know who they were or how big they were or anything. But surprisingly, 70% of them said they're either already using 5G or planning to use it. I was stunned by that, as was UK 5G, to be honest. And so people are starting to look at it. And that's the message I want to give you tonight is you need to start thinking about it. You can see how this is going to transform things. Start thinking about how does it affect my business? How can I use that in my business? Because it's going to take you time to put those plans in place. And by the time you've done them, you know, it will be here. Or maybe you can put a private network in. So, how's it doing in Somerset? Not so good at the moment. So I picked out 4 major towns in Somerset, and he's doing a pretty good job. I don't know how much of the town they're covering. It might only be a small piece of it, but there is a 5G there somewhere. And 3 has got also in Yeovil. So David tells me next year, right, Vodafone, next year is coming. So the message is it's coming. And so what I want to say is every generation of mobile technology always rolls out faster than the previous one. So the fastest one ever in history was 4G. 5G is predicted to roll out even quicker than 4G. And so we know how quickly we got 4G. And so that's what I'm trying to say is, you know, don't sit back thinking, oh, it's years away. It isn't. It's coming, and it's going to, you know, it's going to change everything for you. Because because of the government trials and things that are going on, you need to start to embrace 5G because if you don't, somebody else will. And if we can show that there's demand for it, then there's more incentive for mobile operators to come and put it in. Because they'll go to the places where they think there's the most demand. And the other thing to remember is this is a global standard. So if whatever you're doing works on 5G in this country, it will work in any country. So it gives you that possibility to export. And so I come back to where I started. It's changing the world like never before. So don't get left behind. Thank you.